So thanks, Brian, for that. For those of you who are new to Docker, hopefully you have seen some of the powerful things that it can do. It's always cool to see people realize that you can have the entire a streamlined Ubuntu inside of a little container. I think it's only 188 megabytes, right? The core Ubuntu image. So that's crazy powerful. So next we have Michael Crusoe, the community engineer for Common Workflow Language. So you've heard a little bit about the Common Workflow Language from Brian, and now you're going to hear a lot more from Michael, and I think that this is going to be really great. Do you have the link to your slides? Is it the same?
We can use these. Is the recording on?
Yes. It's
How much time do we
I'd say go for 25 if you want.
have? No. Do some Q&A.
These are good.
Yeah, just good. Hi, everybody. So we saw a little bit about describing a tool using CWL, and so that may be a new concept to you all, so I'm going to kind of step back a moment and explain that. But before I go into that, I'll also kind of talk about how we started and where we're going to kind of give a flavor for this. So the Common Workflow Language, actually, the project began 2 years ago at a special interest group at ISMB called the Bioinformatics Open Source Conference. And before the SIG, they have a Code Fest. So 2 years ago in Boston, several engineers from workflow systems and myself all got to talking about how are we going to solve this problem of porting. First off, workflows are great. Workflow systems are wonderful. If anybody doesn't know that, I can go into why. But we have all these different workflow systems, and portability is a real problem, a real challenge. And so we said, well, let's just try to take the lessons from kind of agile world and open source, and there's been some past standardization efforts that have been very heavyweight and have failed, but let's just try to be lightweight and community-based and consensus-based and see what we can do, see if we can do some good. So the good news is it worked out, right? So more about the story. We had an engineer from the Galaxy project, from Curveverse, who had the Arvados platform, and from Seven Bridges. And then I was there as a tool author and kind of interested person in the community. And so we went and we studied the field, what was out there, was there something we could adopt or modify? We weren't really set out to make a new thing, but it became really apparent that nobody had designed for portability, for interoperability, and for ease of use. We wanted it to be easy to read, easy to write, and so we forced to make a new thing, but we were careful about that. We were trying not to. So we really kept it lightweight and a very open process. It's a free standard. We just released version 1.0 yesterday and had polished it up actually at the Code Fest the day before that. So we're pretty excited to present this, and you've already gotten a taste of it. I'm actually not going to go into the draft 1.0 syntax changes too much. The reference implementation automatically upconverts. So things are if some of the syntax seems a little clunky, we've tightened it up even a bit from these examples. So just to define some terms, what I call a tool is a Linux command line program, and a workflow for us is a series of steps of running those tools and connecting the inputs and outputs. We provide a machine-readable schema, but also kind of a prose specification for implementations. We also have a user guide that's kind of catching up to date. We had a lot of fast development as we really refine things, and so we're expanding that. And we also have a test suite, so we do actively test the different implementations to make sure that they're kind of in sync with each other. The design for this was looking both at running on your laptop, on an academic computing cluster that may not have Docker, but also definitely for cloud systems that use Docker. So there's Docker support built in from the beginning. And what really started as an effort with a bunch of engineers at a code fest with no particular funding or governance structure, so a very lightweight thing, grew into this project that's been adopted and worked on by many organizations. So right now, this is not a top-down, somebody wrote a grant and then said, everybody go do this work. We kind of started from the need, and then we got funding, so I'm now working on this full-time, independently, but supported by 7Bridges. And we're looking to kind of grow our governance as well. So this really is a bottoms-up approach. So this is not a cabal of organizations that are going to tell you have to do things this way. The people at these organizations said, hey, this was a useful thing, and started using it. So many people, there's kind of different development models. Some people like to have that point-and-click interface and a GUI. So the 7Bridges platform is great for doing your tool descriptions and workflows that way. Some of us really love working at the command line and our text editor of choice. We really support that, right? So you can develop in your laptop and then deploy to any of these more full-featured platforms. And so for many people, that's kind of an important thing. I just want to emphasize that usefulness. So we've kind of talked about some of the implementations out there. So 7Bridges has their commercial product and also this new open source rewrite that they're doing. And then we have some from the partners as well. There's just a bit more about the design principles. A big emphasis on trying to have empathy for our users. So if as using this, you're like, this is awkward or weird, let me know. It's my job to kind of make this easier to use for everybody. An important use case is that somebody could generate a graphical user interface for your tool or workflow automatically. So other systems are, there's a design trade-off. Do you use like an embedded language, or do you have something more declarative so you can generate that user interface? So we went that declarative route as much as we could. We saw a bit of this about the linked data, and I'll talk about that more. But we've also just tried to be very pragmatic. I think we're going to get a demo of the 7Bridges system. They're running, as an early adopter, they're running, not the version 1.0 that came out yesterday. But what's great is that they were able to innovate on top of the standard with our extension capability. And the extensions are well marked. And so like the 7Bridges extensions you might see, they don't affect how the tools run other places. But they could maybe come up with new functionality that would affect that, but it's kind of obvious when these things happen. So we're keeping an eye, making this standard flexible and responsive, not getting in the way of people doing new things. So who here knows what an ontology is? One and a half, two, okay, we got half. Okay, right, so ontology is this agreed way to talk about things, to give ideas, identifiers. And so I really like them because they allow specific communities of practitioners to, within themselves, in their expertise, their shared expertise, agree upon a way to talk about things, whether it's file formats, the meaning of a gene, or the components there. And so that way, folks doing the work that I'm doing, we don't have to be experts in all these fields. So we just generically support linked data for metadata, or talking about file formats, or you can kind of decorate your files after the fact. So one specific example I give is with sequencing files. Please.
So you mentioned that you have this. So you also mentioned that you have a way that people can actually develop GUIs, right?
Yeah.
So is that for specific platforms? Like, can you use Spring Framework? Can you use it? Are they for specific?
Yeah. So this would be like procedural graphical user interface generation. So there's enough structure in how we describe tools or workflows that you can automatically, a compliant platform can automatically generate a user interface. And I could see us adding even more hints to improve the look and feel of that as we come to a better sort of consensus understanding of how to go about that. And I think actually most of the 7Bridges extensions were to kind of refine the graphical user interface. So I'm sure as that becomes more widespread, we'll bring even more of those hints into the main standard. Thank you for asking. Yeah, so one way that this is really useful is talking about file formats. The old joke about bioinformatics and other fields is we spend like half our times converting between file formats, and they're not so well defined. They're sort of sub-file formats. Which subversion is this? So the EDAM ontology, which is a totally separate project, we encourage people to use it in the life sciences to talk about their file formats. So an easy example is, oh, you have a FASTQ file. Well, what type of FASTQ file? Which quality score encoding? The EDAM ontology understands those relationships that, this is a subtype of this file format. Whereas if you just had an identifier like a MIME type, you don't necessarily know that relationship. Each platform would have to learn about those relationships. So we're just trying to help the whole field and not having to repeat themselves with this. And again, it helps us scale to new groups and new understandings. So we've had a lot of early adopters, and really the Cloud Institute, the NCI Cloud Pilots, which is kind of the theme of this, have been a huge one, but there's some others you can kind of read about on your own time. And I think we're going to, Kyle, are you going to talk about the dream stuff? Or okay, great. So we'll hear more about that. And I can skip some of these slides. So I'm just going to go into some details about the syntax. And I'll be showing the draft 3 syntax, because that's the most widely used, because we just released version 1.0 yesterday. So when we saw a little bit that I think already with the tool description, again, it's a type thing. So it's really about elevating our command line tools, which maybe when they were written, nobody really thought about that a command line tool has a user interface, and you could have a user, you could think about how to design that better. So here's a sort of formalizing, what is that user interface of a command line tool? How do we construct taking in the inputs and construct that command line? And how do we describe those outputs? When these things are run, we tell implementers that they need to run these tools separately from each other. That way you can kind of detect if accidentally they're pulling in data, because you kind of want to always keep track of which files are going where, both for provenance, but also backing up your data and whatnot. So we really encourage the implementers to keep things very separate and clean, so you have a good understanding of where your data is flowing. So just generally, this is what happens when these implementations, they collect all the inputs the user provides. With a container tech, I don't know if anybody's used Docker at the command line to do what we're doing. Actually, a lot of people, this is their favorite feature about our Docker support, even in the reference implementation, is that it's going to map all your files into the container. And if you had files spread out all different locations, it's really tedious to type that Docker command line out. So even the reference implementation, which is not as fully featured as some of our others, will do this work for you. And we build the command line tool, we actually invoke Docker, execute it, evaluate the output. So it's a pretty simple execution process. And again, we're really trying to help encourage good behavior here. And when there's not so great behavior from our tools, at least kind of contain the damage. There's some bad tools out there that will write files in all sorts of locations or have some interesting opinions about what they can do. We're really just trying to normalize this experience. A feature we support is also streaming input in and out of tools. So a big performance hit can be writing to disk. So if your tools can talk directly to each other by streaming their data, instead of just writing to a random access file and then reading that back again at some other stage, that can really speed things up. So we built that directly into the standard, and I know that the implementations are adding support for that, which is it's a huge performance boost just to stream your data. Please.
So how does this compare to like Galaxy, for example?
Yeah, so one of the Galaxy core developers is one of our co-founders, John Chilton. And I actually came to this project. I was the lead developer of a bioinformatics set of tools, the KHMR suite for Titus Brown. And I was wrapping them for Galaxy, and it was a lot of work. And then I looked around, and there was at the time I knew about 12 other systems. I was like, well, this is way too much work for me to do all this everywhere. So definitely my experience wrapping tools in Galaxy, John's, the whole community's using that, they have a decade of experience of working at that. And their file format evolved kind of very organically. So I give them a lot of respect and a lot of kudos, but it was time, it wasn't portable, right? It had all these, we say it leaked the object model into the file format, which made it inappropriate for portability concerns. Otherwise, we would have just told, hey, everybody go use Galaxy's format. So it takes a lot of inspiration from it, but we also made the command line rendering more structured. So there they have that template with the Python, embedded Python. We don't do that. You can use JavaScript as an optional feature sometimes in your CWL tool, but we bound it much more closely, and we better define what you can do in that circumstance. In Galaxy, you could do anything with you could reference anything within the Galaxy systems data model, which people, if you make that available, people use it. And so it made the tools very portable. So, and I think it's also like they did XML at the time. Now this is a YAML syntax. So I find it a lot easier to read and write as well. Go ahead.
How do you contrast this with gene pattern?
I'm not familiar with gene pattern offhand. Do you want to describe it real quick?
It's pretty broad, right?
That's from Road,
They have I think they said in a talk recently they had actually 10 different platforms. I think they're converging on one. So
you're thinking genome space. Gene pattern is much more analogous to this wrapping around the front command line.
yeah, so there's a lot of, I'm maintaining like a wiki list of command line tool and workflow systems. I think so. They sound familiar, but I don't remember their specifics. So I can say broadly how what the field is doing. We have some more make-like systems where you do you render the command line as a pattern. So you're sort of doing text replacement to figure out the command line. It's maybe a little faster to write, but it's less structured. You can't really reason about what's going on. It doesn't support that user interface generation use case. So if it's one of those. Another common way that people do these command line wrappers is they use kind of taking Galaxy's thing but further. So it's Python or some like DSL everywhere. Again, there's, for those who kind of work in that, they're an analyst, this is their full-time job, they have an IDE, maybe that's a good fit, but that makes portability and interoperability very difficult. And it's not so, the learning curve is a bit higher. So I don't know that one in particular, but we can look at some point. So I'm just going to step us through some example, just to code, just to get a feeling for what these look like. So this is SAM tools. I think probably people are fairly familiar with. So every CWL file from draft 3 onward actually explicitly says which version it is, and so here we have a command line tool. It could be a workflow. We support kind of documentation along the way. This shows up both in DocStore, but also other graphical displays. Here, we're specifying that you have to, because it's under requirements, use this Docker image, but it could have been a hint. You can optionally use this Docker image. And so that Docker pull could have been a DocStore. So I guess we wouldn't specify DocStore. We would have used the quay.io. Yeah, so this is where you put your quay.io URL. As a hint, we would actually, I should change this slide. It should be a hint to use Docker, because some people might want to run your tool in a non-Docker system. And then we have a section about, and I'll go in detail about these sections, our inputs, our outputs, and then just sort of the base command. So let's look at in detail. So that our support for linked data means we can use any vocabulary to add metadata to our descriptions. So here we're actually giving some information about who created this tool itself, and we're even using the EDAM ontology to say what sort of tool it is. Since they have an ontology about different bioinformatic operations, we can even help categorize this tool, which could be really useful in a user interface that has 300 or 3,000 tools. And one thing as a community we're doing, though, is coming to some standardized best practices around the metadata, recommended vocabularies. We know it's hard, if you're new to this, to pick which one to do. So that's a next step for us, but we want to get our standard out first. So again, the runtime requirement, it could be Docker, it could be a hint about using it from some other environment. You can even specify minimum and maximum, memory, disk space, cores to give a hint for some of the schedulers. And I think I explained this already. And so now we're back looking at that input parameter section. And here it's pretty, the position isn't required, but there's this idea that you'll have your inputs, you'll say the type, and then the input binding gives a hint, how do we construct this command line? So position just means, you just represent it right there in the command line, but maybe we need to add a prefix, dash, dash, output equals, whatever that is, this is where we provide that information. And this is one of the things we've tightened up in version 1.0, but that's still permeating for the community. And again, the output, right? Where are the output files, or maybe we're taking the standard out or the standard error output and parsing that somehow. And so here we're saying, nope, we actually specified the output name in the input, so we'll go reference that. That's what that $ parentheses is our parameter references. So here it is all together. So I took out a couple components here. So we have the inputs on the right. And what I didn't show you is how if you're executing these tools from the command line, you can, did you have a job object or did you pass in options to CWL tool?
I had the input object, a JSON.
Great. Yep, so you can have an input object. It's either in JSON or YAML. And so it just sets up any starting parameters and where your files are. And so here we can kind of see it's going to take all this together, take our input bindings. I mean, this is a very simple example. And then here's our centrals command. It would be without the parentheses. So we're showing this as a list because that's how we execute it. So that's just a simplistic version. So, okay, we talked about command line tools, and then we were talking about workflows. How do we bring this all together? So in CWL, we define workflows as the connections between tools or invocations of a tool. So it's a connection between the output of some tool and the input of some other tool. And you can execute tools multiple times, so it's really kind of between steps. One thing that's nice is in our object model, a workflow is a tool. So sub-workflows came for free. They're just like some other tool in your system. So this is a little complicated, so I'll just walk us through this map here. So here we've got a simple workflow. It's referencing two different tools. Actually, we've updated the syntax, the Unix grep tool and the word count tool. We have the overall inputs for the workflow itself. Those flow into the particular step. So here's the first step, grep. And we're mapping the inputs for this tool, which are defined in this other file, to the inputs for the overall workflow. For the second step, we take one of its inputs comes from the previous step. And I'll come to the scatter data here. And then at the end, we have the outputs for the output for the entire workflow. And this one's very simple, so it only just comes from this one last step. We can obviously do more complicated things than this. This also demonstrates our scatter getter feature. So in this instance, we're saying for the file, you can actually take an array of files in and run them in parallel. So this tool doesn't know about how running in parallel works, but we're kind of teaching how as we import it, as we're referencing it in the workflow. If you wanted to scatter over more than one parameter, we can even specify what sort of scatter do, like a dot product, a nested product, etc. Got a question?
Yeah, I see that you're resolving dependencies and executing parallel jobs. Can you give us a preview about how you plan to deal with iteration and conditionals?
So I'm curious what you mean by iteration, because people have different uses of that word.
Okay, do this 5 times.
Do it 5 times. So looping for.
Until.
Yeah, if it's looping over an input, like do it 5 times for these 5 different inputs, you can do that right now. That's our scatter feature. But a specific, a loop until or a loop number of time, we found that there was less consensus or shared understanding in the community about how best to represent that. And not all of the workflow systems that have been working with us have that feature. So what we really tried to do for version 1.0 was to really focus on this core commonality. And then through a lot of fast iterations. And now we're really going to slow down for things out here. So we have some ideas, absolutely, but it's really about, we're now going to switch our development model, where sometimes the standard led the implementations, to the other way around. We're really not going to accept any new features until we have 2 separate implementations of them. So it's up to the implementation community that's participating with us to help us figure out that sort of syntax. People ask for it, absolutely. But just kind of, this is that careful dance we have to do. The good news is for, some people want workflow branching, right? So you come to a point and you're going to make a decision, and it's going to be 2 or more totally different paths. And right now, we really suggest that you can make that decision kind of outside the workflow and then just launch the sub-workflow. Another approach that some communities do is they'll have a program up front that examines your experimental design and it will output CWL for that particular design. So if you can make the decision up front about which path to take, because it's related to your experimental design, then they'll just render it up front. If it's something you won't know until you get to that moment, how to make that decision, then you should break it up into sub-workflows and run them separately.
Right. So I'm looking at this, for example, for molecular dynamics simulations, right?
Okay.
You run with several different parameters and you run it many times and you come. So is that possible with this thing, or are you saying that your system is not designed to do? I mean, at this time you're not handling.
Yeah. So if there's,
Trying to figure out which ones.
it's okay. Yeah. If there are variations in your parameters, you could scatter over that. But I think maybe that's not what you were trying to say. If you're just saying run it 5 times the same way, like it's a stochastic thing, and you're just trying to, you could manually say run it 5 times and then collect the output, but there's not, you just have to put the step in there 5 times,
Well,
right?
I'm mapping what I know about workflows to what you're describing and
Yeah.
completeness. And I think that your scatter probably handles much of what I wanted to do with the while loop.
Great.
But I can see also that you need an outside orchestration layer to handle forks and joins and these conditionals.
So you could, yeah, it depends. Yeah, so this is many communities of practice, many workflows.
If I could make one comment. Yeah, I think that's something that I'd be curious to get your thoughts on this, Michael. That's something that's left to the implementers. So we thought about orchestration, conditionals, work, things like that.
Yeah.
But the core spec is so powerful that we can easily add those orchestration features as we need to. We have never needed to, we can work very easily with this spec. I think different people want to orchestrate or use different heuristics, and it makes sense that if there are commonalities, maybe we'll consider bringing it back.
So if it's about resource planning, but doesn't actually affect the results or how they're done, that's really like the implementation specific detail. There could be some hints developed that should be common to all the platforms, and those will emerge naturally, and we'll bring those in. So absolutely, it's just, this is how the standardization process works. So I imagine that specific implementations will add these things you're asking for, and they'll make their way into the main standard as consensus is reached. But you could still have a valid CW file that has these extensions in them. So, another question?
Yeah, okay, this is, I have this bad feeling that this is one of these really dumb questions, but I'm stumbling right now that when I see the file specifications, where are they living?
Sure. So our model really is the POSIX Linux model. Things are on disk. If they're not on disk because you're streaming them in, like that could be an enhancement that the workflow system provides for you. If your files normally live in like an object store or a database or whatever, that's an area of kind of growth. So
one, if my modules are communicating via REST, then that's not part of this at the moment.
Yeah.
So two, whose file system? You have all these containers that are separate Linuxes. Whose file system are we talking about?
So it's up to the implementation to do all that staging for you. Because there's that initial representation when we kick off a job or a workflow where those URLs, it could be on the local file system. Because that initial job input document, we do the same thing for the workflow to kick off a workflow. Those are URLs to the file. In fact, in the 1.0, we've kind of clarified that we now call them locations because they might not be a path. But that input document is not really portable, right? Because it's when I'm running this instance. So that could be a URL to a Google object store or Amazon's object store or some other syntax that's specific. And then as far as representing them on disk and moving things around in between steps, the implementation takes care of that. So it could be that it's a named pipe on disk because we know it supports streaming and they'll stream it in from an object store. Great, it's fast, everybody benefits. So, yeah. So we explicitly don't have a support for web services as like a first level construct. You obviously could run a fancy wget or some other web service runner as a tool, but it's not like, it's something people ask for, it's likely to come soon. I would say within the year, but we don't do that yet. We're just trying to get the core out there to bring all these other things on. All right.
Just in the interest of time, I'll mention we'll have a all hands at the end where you can, if you have additional questions for Michael, then we can all get together and
Yeah.
ask.
So I'm officially over time. Should I keep going a bit? There's not too much left.
Oh, no problem.
Yep.
Totally fine.
So we were just showing the workflows. Oh, was that my last slide? Well, that was convenient. No, that was my last slide. So there's like a lot, clearly there's a lot more details here. There's a lot you'll learn by doing. And I think we'll have a bit of a doing and asking questions again. So yeah, it was good timing.
All right.
Thank you.